Properties.com.
Okay, students, today we are going to discuss a DPP with detailed explanation. This is very useful for the first three chapters, that is atomic structure, periodic table, and chemical bonding. Based upon these three chapters, this DPP is made. Okay, so let's solve it and know the current level of your preparation. Okay, all three chapters at a time. So here you can see the isostructural species. Okay, first question is isostructural species, isostructural species. Okay, uh, which are which have same shape and hybridization. Okay, so same shape and hybridization. Actually, sometimes if hybridization is same, it does not mean that shape will be same. For the shape, lone pair also will differ. Okay, so here answer is BF4 and NH4. Okay, both will have sp3 hybridization with no lone pair. With no lone pair. Second type of orbitals of hybrid orbitals of nitrogen, that is hybridization of NO2 plus, NO3 minus and NH4 plus. Okay, in NO2 plus, if you give the positive charge to the nitrogen, that means it is as good as a carbon, so it will be linear shape, therefore hybridization will be sp. And in case of the NO3 minus, in case of the NO3 minus, there will be one lone pair toward the coordinate covalent bond, one pi bond here and one minus. So 1, 2, 3, 3 sigma bond are there, therefore sp2 hybridization. And in NH4 I am writing it here, NH4 positive, nitrogen will form all the 4 sigma bonds. All the 4 sigma bonds, therefore it will be sp3 hybridization. Okay, so answer is sp, sp2 and sp3. Then formal charge on oxygen of PO bonds. Okay, so actually PO4 3 negative, PO4 3 negative, therefore there will be one double bond. Okay, only one place it will be double bond, and in all other places, it will be single bond, PO4 3 negative. Okay, so formal charge, if you distribute it among the 4, that means each one will get the 0.75, and oxygen is more electronegative, therefore it is minus 0.75. Okay, so this is the answer and this is the short trick. This you can say as a short trick to understand the answer very fast. Okay, next, diatomic species is listed below and order of bond order. It is just a memory based, so you can solve it and you will get the answer according to the molecular orbital theory. Okay, so these are the some questions. Let's see the next slide. Okay, so let me clear all of them. Okay, here is the next slide, and answers are, which of the following is the correct decreasing order? Okay, decreasing order of bond length. Actually, bond length is question is given as a trick. As a trick, you have to find out the bond order. You have to find out the bond order. Already, how to find the bond order in fraction of seconds. There is a lecture uploaded. By using that, SO4 2 negative bond order is 1, PO4 3 negative bond order is 5 by 4, SO4 2 negative bond order is 6 by 4, ClO4 bond order is 7 by 4. More is the bond order. In the bond parameter we have studied in our bond parameter lecture of the chemical bonding. you can find bond length is inversely proportional to bond order. Okay, there is a complete devoted lecture for the bond parameter in the chemical bonding. Okay, now next formal charge of oxygen atom 1, 2, 3. See here, this is 1. Okay, so there is a trick, oxygen, there is a trick. Wherever it is a 3 bonds, then it will be +1. Wherever it is 2 bond, it will be 0. 1 bond, it will be -1. Okay, this trick also already explained in the resonance structure. So this answer double bond, therefore 0, triple bond, therefore +1, single bond, therefore -1. So answer is First, first oxygen atom is +1. Second oxygen atom is this one 0. Third oxygen atom is -1. Okay. Molecular orbital shown in the diagram described as. Here there is a opposite side is there. Okay. So because of the opposite side, this will be star. Okay. And it is sideways overlap. Therefore, it is pi. So this was shown on the uh, digital board, how to identify the type of molecular orbital in our video lecture. Okay, so how to identify type of molecular orbital in the digital board, it was explained. You can go through that. Okay, pi bond, that means sideways overlap, repelling with each other, that means star. Okay, so anyhow, that is completely detailedly explained already. Understood? So let's see the next slide. Okay. Okay, next slide is about the ionic nature. Next question is about the ionic nature. Okay, least ionic. Least ionic means here we can find cation is same everywhere and anion is different. Okay, anion is different. Therefore, we have to compare with the polarizability. Polarizability directly proportional to size. So, once size increases according to Fajan's rule, polarization increases, covalent increases, okay, and covalent increases, ionic decreases. Okay, there is a separate exclusive lecture for the Fajan's rule. Go through that. Okay, I will give you the link in the description box of all the 3 chapter, whatever the topic I am telling you. If you are interested to get good marks in the smart study, you can do it. Okay. Now here it is a square planar complex. Square planar complex means it is DsP2 hybridization. Okay. So main problem comes, what is the d orbital? We got 5 d orbital, dxy, dyz, dzx. Okay. So here and dx square minus y square and dz square. So which orbital to use what? Okay. Whenever it is dsp2, d orbital used will be x square minus y square, and there is no problem of the actually px and py. Okay, so why it is, and with the explanation what will be the orbital in sp3d and what will be the orbital in sp3d2, that is also explained in the Vesper theory hybridization video lecture. Okay, then pair of species of oxygen and their magnetic behavior. So here already known that O2 is paramagnetic. To explain the paramagnetic nature of O2 only, molecular orbital theory, the main cause of the molecular orbital theory is oxygen. According to hybridization and according to Vesper theory, they were not able to explain the paramagnetic nature. So it contains 2 unpaired electron and it will contain odd number of electron. Therefore, both will be paramagnetic. Okay. So these are the some explanation about the up to this question. Okay, let's see the next one. Okay, so next one, atomic radii. Actually, people, when this is a previous examination question, when people come out from the examination hall, they ask, sir, how to remember these many radius are there. Actually, this is not the question of remembering. This is only comparison in the NCRT. Okay, all of you are aware or not aware, there is a series. There is a series going on in the which chem where NCRT line by line. Okay, especially inorganic and solution chapter. So where we will read the NCRT line by line. Okay, then you will not be out of the syllabus and you will understand the only required things. Okay, So in that I have explained neon have the van der Waal radius, fluorine have the covalent radius. Okay. So even though actually left to right atomic radius it should must increase. So fluorine should be higher and neon should be lower. But because of this exception, people say it is exception, you have to remember. But very rarely I say exception. If I say exception also, I will give you the reason. So because of the van der Waal radius, neon atomic radius is more, fluorine atomic radius is less. See, you can check. This is not about the values. You have to know the which is having less, which is having more. Okay. So next, first ionization enthalpy of sodium, magnesium, aluminum, and silicon. And this reason was clearly explained with the graph. Okay, so reason I will tell you in short because we have to cover a lot of questions. 3s2 being fully filled subshell. Exceptionally, its ionization energy is more than the next aluminum. Okay, so here this is the where you have to be very careful. Next, the consider the isoelectronic species. So in the isoelectronic species, proton should be less, then radius will be more. What will be more? Radius will be more. So least number of protons, that is 8, and here it is 9, here it is 11, here it is 12. Therefore, this is the correct order. Okay. So I hope all of you understood. Now let's go to the next slide. Okay. So here the formation of oxide ion, very important and easiest question. See, you can find here delta H is negative, that means liberated. First electron is invited, but second electron is repelled. Question is why it is unfavorable. Okay. Even though it is forming oxygen 2 negative. Why? Because stability by noble gas. It is very difficult for oxygen, but still it is doing. Like few students hard work because they know if I am hard working today, my life is going to be stable. But some people start enjoying from the class 11th and 12th, and when they reach after the examination, they will ask their parents 25 to 30 lakhs as a college fee for the engineering student and 60 to 1 crore for the medical student. Okay. But if the same students start hard working, like here, oxygen, no, I have to put so much of energy. So if you put 4 to 5 months of energy or at least 2 years simple energy, then you are going to suppose if you are joining a NIT or IIT, your BTech will be completed in 2 to 3 lakhs. And after that, what will happen? Your job is almost secure. But if you don't work hard and relax like first electron only, you are satisfied. Then what happens? You will pay 25 to 30 lakhs, and by the time you will come out, you will have a fake offer letter. Okay, you will get suppose 20 lakhs package, but there you will work not more than 1 month. You will be thrown out. Okay, so and the same way if you are joining the hard working and if you join AIMS, okay, if you join AIMS, definitely it is going to be within the 50,000 you are going to complete your MBBS. Okay, so 4 to 5 months of now also if you start 4 to 5 months completely rigorous hard work or 2 years of normal hard work. If you are in the joining phase session in the first 11th class, first initial session, 2 years of normal, moderately hard working also, you can save around 22 lakhs. If you are engineering student, you can save 59.5 lakhs minimum. I am telling you for the medical student. And when you are tied with suppose your name and here BTech IIT or your name MBBS AIMS, that reputation itself will be very high. Okay. So here it knows that I am putting up so much of energy, but still why it is doing? Because it knows I will stable, I will become lifelong, I will be stable. Okay. Then electronic configuration of gadolinium. Okay. So actually people think like this, but answer is third option. Okay. You can cross check with the Google. Okay, next. A bulb emits a radiation of 4,500 angstrom, and it is radiated as 150 watt. Actually 150 watt means 150 joule per second, and only 8% of it is, that means 12 joules is converted into energy. 12 joules is converted into energy. Then E is equal to N into Hc upon lambda. Here energy we got total in per second is 12 joules, and number of moles we have to find out. I think everybody know the N value and C value. So after substituting N value and C value 4500, and it is given as angstrom 10 to the power of minus 10 meter. Then you will get an answer of 3. Okay. Then according to Bohr's theory, electron energy of hydrogen atom is nth orbit. Very important. And calculate the longest wavelength to remove electron from helium, and it is third orbit. So n value how much I will put 3, and z value how much I will put 2. So simply what I have done, see here, Hc upon lambda is equal to same formula I have substituted, 2 square here and 3 square here. So I will substitute and simplify, then I will get answer as 2055 angstrom. Okay, is it clear to all of you? Now this is a shortcut given already, but most of the students that time neglected, and now they will start feeling bad. Okay, so here 5,500 volts, that means V is equal to 500. Electron charge is 1.6 into 10 to the power of minus 19. Mass of electron is 9.1 into 10 to the power of minus 31. 2 is as it is, 6.626 into 10 to the power of minus 34. If I substitute, I will get second option. I will get which option? Second option. Okay. Okay, here wavelength characteristics of X-ray, sorry. Okay, wavelength characteristics of X-ray is given. Wavelength characteristics of X-ray is given, and here we will use formula of, here we will use a formula, lambda 1 by lambda 2 is equal to Z2 square by Z1 square. Here you have to be very careful, 2 and Z. Understood? And here it is given as a iron. So iron means Z value will be 26, and its wavelength lambda 1, 1.931 into 10 to the power of minus 8, and lambda 2, 2.289 into 10 to the power of minus 8, and Z2 you have to find out. So if you find out, you will get answer as a 24. Therefore, element will be chromium. Okay. So these calculations, I think you can do it. And I hope you all will note down this. And this is going to be helpful before examination. Okay. Keep all these DPPs together before the examination when you feel proud that I am completed my syllabus. Okay. Then that time you can cross check your attentiveness and level of the understanding with the these DPPs only. That's why this DPP session is given to cross check your preparation. Understood? So 3000 angstrom falls over the metallic surface having wavelength. See, problem is that both wavelengths are given, but energy in joules they want. So once you have a problem, and which can have a trick. Okay. So easy way to convert H into C, if you multiply, you will get in electron volts 12400. Okay. This directly you can put down. Okay. You can make it as a short trick. It will save up a lot of time. 1 minute saved means one question extra you can attempt. So extra attempt means 4 marks. And so this you will get on simplification 1.033 electron volt. But answer they want in the joules. Okay. What is the answer? 1.6 into 10 to the power of minus 19 joules. So many traps are there, given wavelength, but asking energy in joules. Okay. So I think you will not be in that trap. Okay. So let's see the next one. Okay, next one is here. Again, same trick. See, here also it is applicable 12400. Okay, but there it was angstrom. Now it is what it is here, nanometer. That's why 1240. Answer will be in electron volt. Okay, whenever energy need to be converted into answer electron volt. So the energy given is 4.13 electron volt. See here, everywhere you have to be very cautious. Okay, so that means this much energy it is giving. So copper will give, but it requires 4.8. It will not give. As silver require 4.3, so it will not give electron. 4.7 it will not give. 6 point it will not give. 4.1. So if the required energy is more than the given energy, sorry, less than the given energy, they only will give you the electron. So these metals have the energy less than the given energy. Our given energy is 4.13. Their required energy is this much. Therefore, these four metals will liberate. Okay, then when an electron jumps from n is equal to 4 to 2, so here formula will be 1 upon n1 square minus 1 upon n2 square into z square. So for first I am considering as a hydrogen, for second I am considering as a helium. Okay, so I want n1 and n2 of hydrogen. So directly I will put for helium what they have given, 4 square and 2 square. See, 4 square and 2 square. And here z square. Z is how much? 2. So helium. Okay, 2 square, if I send it inside, this 2 square and this 2 square will get cancelled. 2 square and 1 square. Now here z is not here. So that means 1 square. So comparison, n1 is equal to 2, n2 is equal to 1. So here it will be 2 to 1. Therefore answer will be 2. Okay. Then if hydrogen atom is bombarded with 12.75, very tricky and favorite question. Okay. So already it will have minus 13.6. Okay. And it is given with 12.75. So the energy left over will be minus 0.85. So by using the energy formula, En formula in terms of the electron volt, we can find out that energy level in which it is available is fourth energy level by using the energy level formula. So when it falls from the fourth energy level to first energy level, this is a shortcut. I have told you, sigma n2 minus n1 de-excited to ground state, fourth energy level to first energy level, sigma 3. So sigma 3 means 3 plus 2 plus 1. Therefore it is 6 spectral lines will be generated. How many spectral lines? 6 spectral lines will be generated. I think all of you understood now. Let's move on to the final page of the DPP discussion. Okay. See here, this is a very complicated. If I start teaching you on a normal board, it will take time for me to draw itself. Okay. So, and detailed explanation, if it is wrong, what should be the correct answer? That is what I am going to tell you. Okay. How many graphs are represented correctly? Okay. See, according to this graph, it is directly proportional, but lambda is equal to h upon p, inversely proportional. That's why this graph is incorrect. And here, if I increase the frequency, kinetic energy will increase, and this is the threshold frequency, but it is given constant. That's why it is wrong. Okay, velocity of electron in nth orbit is inversely proportional to n, therefore it will be hyperbola, but not like line like this. Here it is given 2s level. 2s level will have only one node, but here you can see how many nodes are there? Two nodes. That's why it is wrong. And here it is given as a 3s. So here you can find two nodes. Exactly correct. So out of the 5 graph, only 5th graph is correct. Okay. Then Z is equal to 26. That means it is of iron atomic number. Its electronic configuration will be 4s to 3d6. Okay. So, and here root 5.9. Okay. So n into n plus 2 is equal to 5.9. Therefore, on squaring both side and comparing, n value will get it as a 5. That means 5 unpaired electron must be there. Okay. So 1 unpaired, 2 electron will be removed here. So 3d6 will be there. That means one more electron is to be removed. That means plus 3 oxidation number is required. When this electron also removed, then 2 electron plus 2, 1 electron plus 3. So when total 3 electrons are removed, plus 3 oxidation state. Okay. So this is all about the short tricks and fastest DPP discussion with absolutely wonderful questions selected. Okay.